So think about this challenge we always face. How do you evaluate things accurately, consistently, and, well, quickly? Whether it's grading essays, making medical decisions, or even figuring out cancer treatments.
Yeah, getting that expert-level judgment is crucial, but it's traditionally been slow, expensive, and sometimes, frankly, a bit inconsistent.
Exactly. But today, we're diving deep into two tech solutions that are really trying to tackle this head-on. We're talking LLM-as-a-Judge and multi-agent systems, or MAS.
That's fascinating stuff. Large language models, LLMs, aren't just writing text anymore. They're starting to evaluate it, like AI judges.
And then you have these multi-agent systems where you basically build teams of these specialized AIs, including maybe those AI judges, to work together on really complex problems.
It really is a shift. You get the nuanced judgment from the LLM and the collaborative power and scale from the MAS framework. So our mission today is to unpack this for you. We'll look at applications, especially in healthcare, like cancer care.
Which is incredibly complex.
Right. And we'll cover the amazing benefits, but also, importantly, the hurdles and challenges we still need to figure out.
Okay, let's start with LLM-as-a-Judge. For evaluation, we've kind of had two main approaches up till now, haven't we?
Pretty much. On one hand, you've got human experts. That's the gold standard, right? Deep, nuanced, holistic reasoning.
But the downsides are obvious. Super expensive, doesn't scale well.
And humans can be inconsistent. Even the best experts have off days or slight disagreements.
True. Then on the other side, before these big LMs came along, we had automated metrics.
Right, things like BLAU or Bruges scores, often used in, say, machine translation. They're consistent, they scale.
But they're often quite superficial, aren't they? They check for overlap, but miss the deeper meaning, like evaluating a story or a complex argument. They struggle there.
Exactly. They don't capture that complex reasoning. So this is where models like GPT-4, these powerful LLMs, are stepping in. They seem to offer this potential, this idea of combining the scale of automation with the context-aware reasoning of an expert.
Sort of the best of both worlds.
That's the hope. And they can even handle multimodal inputs now. Text, images, audio, making the evaluation potentially even richer.
So the big question is, how do they actually do the judging?
Well, one pretty intuitive way is just generating scores. You ask the LLM to rate something on a scale, maybe 1 to 10, or even a continuous score.
Like a prompt saying, rate how helpful this response is from 1 to 10.
Exactly. Rate helpfulness, relevance, accuracy, detail. Simple enough.
Okay, what else?
Another method, and one that seems to align quite well with how humans evaluate, is pairwise comparison.
Ah, like A versus B.
Precisely. You give the LLM two options, say two summaries, and ask it which one is better. It's a well-established method.
You can tweak that, right? Like allow for ties, or maybe distinguish between both are good and both are bad.
Yes, exactly. You can have 2, 3, even 4 options sometimes, judging win, tie, or loss. It forces a direct comparison, which is often very informative.
Makes sense. And when it comes to picking the model to be the judge, are we talking mainly the big players like GPT-4?
Well, strong general models like GPT-4 have definitely shown high accuracy and consistency, sometimes comparing favorably even to human evaluators in terms of stability.
But it's not only them, is it? What about open source?
No, absolutely not. There's really exciting work happening with open source models too. Models like Qwen 2.57b Instruct, for instance, have shown really exceptional evaluation skills, sometimes even outperforming GPT 3.5 Turbo in certain areas.
That's great news. It means more options, more accessibility.
Definitely. It suggests a really vibrant future for this whole LLM-as-a-Judge idea, with lots of different models potentially playing a role.
So for you listening, the takeaway here is that this could lead to evaluations that are just faster, much more consistent, and way more cost-effective across, well, almost anything. Content creation, customer service, research.
The potential impact is really broad.
Okay, now let's widen the lens a bit and talk about multi-agent systems, MAS.
Right. So if LLM-as-a-Judge is about the evaluation capability, MAS is about collaboration.
Instead of one giant AI doing everything.
Exactly. You have a network of specialized AI agents. Think of each agent as its own little entity. It has goals, knowledge, it can make decisions, take actions, it could be software, or even a robot.
And the key is that they work together.
That's the core idea. They collaborate to achieve goals that might be too complex for any single agent. A key thing is that each agent usually has only a local view. It doesn't know everything that's happening everywhere.
So it's decentralized.
Yes, decentralized and often self-organizing. Agents perceive their environment through text, sensors, data feeds. They process this in their brain, reason, decide, and then act. and those actions affect the environment or other agents. It's a constant cycle.
Interesting. What kinds of MAS setups do we usually see?
You can broadly categorize them. There are cooperative systems where all agents share the same goal, like maybe optimizing patient flow in a hospital.
Okay, everyone pulling in the same direction.
Then you have competitive or adversarial systems. Here, agents have conflicting goals. Think maybe in medical imaging, different agents might compete to find the best interpretation or diagnosis, perhaps using game theory.
A bit like a debate team.
Sort of. And then there are mixed agent systems, which combine cooperation and competition, just like many real-world situations.
So what makes MAS so powerful? Why not just build one big super AI?
Well, there are several advantages. Scalability is a big one. You just distribute the work across more agents. Robustness, too. If one agent fails, the whole system doesn't necessarily collapse.
That makes sense. Resilience.
They're also incredibly flexible, adapting to changes in real time. And efficient, they can often solve problems faster by dividing tasks and working in parallel. Think specialization.
Like having different experts on a team.
Exactly. Modularity means you can develop agents independently for specific tasks. This pooling of specialized insights often leads to improved decision-making, and they can offer real-time responses, which is critical in many fields.
You mentioned something interesting earlier, emergent behavior. What's that about?
Yes. That's one of the most fascinating aspects of MAS. It's when the simple, local interactions between individual agents lead to complex, sometimes completely unexpected, system-wide patterns or outcomes.
Unexpected, like what?
The classic example is phantom traffic jams, where traffic slows to a crawl for no apparent reason like an accident. It can happen just from small individual variations in braking, by drivers cascading down the line, simple individual rules, complex collective result.
Wow. Okay, so even with relatively simple agents, the overall system behavior can be hard to predict.
Precisely. It highlights the power and also some of the challenges of these decentralized systems.
So for you listening, MAS is really about tackling complexity. It enables AI to handle problems that are just too big or dynamic for a single model, leading to more adaptable, robust solutions everywhere.
Right. Now let's bring these two concepts, LLM judges and collaborative MAS, together. Where are they making a real difference? Healthcare is a prime example, especially in cancer care management.
Yeah, cancer care is unbelievably complex. You have, 20 million diagnoses globally each year?
Yeah.
Hundreds of different tumor types.
Exactly. And creating the right personalized treatment plan involves synthesizing just vast amounts of data imaging, pathology, genomics, patient history, plus expertise from many different specialists.
That's traditionally the job of the molecular tumor boards, the MTBs, right? Teams of doctors getting together.
Correct. You have radiologists, pathologists, oncologists, genetic counselors, all analyzing complex data, usually genomic sequencing, to come up with treatment recommendations.
But getting everyone in the same room, accessing all the needed data, that's tough.
It is. Time constraints, getting the right experts, accessing diverse data sets, collaborating between different hospitals. These are real limitations of traditional in-person MTBs.
So virtual MTBs, VMTBs, started to address some of that.
Yes, VMTBs have shown real value. They overcome logistical barriers, can expand treatment options by bringing in wider expertise or data, potentially speed up treatment decisions, and improve patient outcomes. There was a case in Turkey, for instance.
Oh, yeah.
A VMTB discussion for a patient with a rare BRAF mutation actually led to finding an approved reimbursed treatment that resulted in a complete response for the patient. That might not have happened without that virtual collaboration.
That's incredible. A direct impact.
Absolutely. And now we're seeing the next evolution with systems like Microsoft's Healthcare Agent Orchestrator, or HAO.
Okay, tell me about HAO. Is this an MAS?
It is. It's an LLM-driven multi-agent system specifically built for cancer care. It essentially mimics that collaborative MTB structure, but with AI agents coordinated by a central orchestrator.
So AI specialists instead of human specialists.
Kind of. It uses specialized agents like a patient history agent, a radiology agent, pathology staging, even a clinical trials agent. Each focuses on its piece of the puzzle.
And the orchestrator manages them.
Exactly. It's like the conductor. It figures out which agents are relevant for a specific patient case, plans how they interact, manages a shared memory so they're all working off the same information, and importantly, it has verification checkpoints.
For safety and accuracy.
Yes, and explainability. It keeps an auditable trail of what each agent did and the intermediate results. That's critical for trust in healthcare.
Makes sense. How does a clinician actually use this?
It's designed for seamless integration. For example, it can plug into Microsoft Teams so clinicians can just converse with the orchestrator. And the outputs can be pushed into standard tools like Word or PowerPoint, reducing workflow disruption.
Wow. Any real-world examples of agents working with HAO?
Yeah, Page.ai has an agent called Alba. It's a third-party agent that connects into HAO and can provide real-time digital pathology insights like tumor grade or biomarker status directly from analyzing whole slide images just through conversation.
That's pretty amazing, like having an instant pathology consult.
It's moving in that direction, and the tangible benefits we're seeing from these kinds of MAS and healthcare are really compelling.
Like what kind of numbers?
We're seeing things like up to a 30% improvement in early disease diagnosis. Breast cancer detection is one example.
Yeah.
A significant, like 26% reduction in adverse drug events.
That's huge for patient safety.
Absolutely. And operational improvements too. 30% shorter patient wait times in some cases, better hospital resource allocation. Plus, predictions of around a 45% ROI in areas like drug discovery and developing personalized treatments.
So it's not just about clinical decisions, but the whole healthcare system efficiency.
Right. And these MAS principles apply beyond healthcare too. Think bug report summarization for software teams or automated essay grading in education. Anywhere you have complex, data-heavy collaborative tasks.
So for you, the listener, this signals a future where healthcare could be dramatically more efficient, accurate, and truly personalized. The potential to improve outcomes and manage costs is just immense.
It really is.
Okay, but let's bump the brakes a little. It sounds incredible, but there must be challenges, right?
Yeah.
Especially around reliability.
Well, absolutely. We need to be realistic. LLMs, as judges for all their strengths, still have inherent issues. Hallucinations are a big one.
Where they just confidently state things that aren't true.
Exactly. Plausible sounding, but incorrect. And biases are another major concern.
What kind of bias?
Things like length bias, preferring longer answers just because they're longer. Positional bias, favoring information presented first or last. Even concreteness bias.
And these biases can really skew the evaluations.
Definitely. There was a finding that GPT-4, when asked to compare its own response to another, preferred its own response almost 88% of the time.
Wow, compared to humans who preferred their own work less than half the time.
Around 47, 48%, yeah. So that shows a significant self-preference bias that needs careful handling.
Okay, so how do we fix that? How do we make these AI judges more reliable and fair?
Well, there are strategies. For prompt design, simple things like randomly swapping the order of options A and B can help reduce that positional bias.
Mark, what else?
Fine-tuning the LLMs specifically for evaluation tasks using what are called meta-evaluation datasets can teach them the nuances of judging and reduce some inherent biases. And then there's optimizing the results.
How so?
Instead of relying on one judgment, you can combine results from multiple rounds or even multiple different LLMs. Use techniques like majority voting or taking the mean score. Also, setting the LLM's temperature setting to 0 makes its output deterministic more stable.
So redundancy and careful setup can help.
They can mitigate some of the risks, yes, but the challenges extend beyond just the LLM judges when we talk about MAS in healthcare.
Right, the whole system.
Yeah.
What are the big hurdles there?
Data interoperability is a massive one. Getting different electronic health record systems, EHRs, to actually talk to each other seamlessly is still a major challenge.
Yeah, I've heard that's a nightmare.
It can be. Then privacy. You have sensitive data being processed potentially across multiple agents, maybe even in different jurisdictions. You need incredibly robust privacy safeguards.
And regulations. Is the governance keeping up?
That's another issue. Frameworks are still evolving. Only about 30% of countries have really well-established governance for this level of AI in healthcare. And standard validation methods for AI often don't capture that emergent behavior risk in MAS.
The unpredictable stuff.
Exactly. We also can't ignore algorithmic bias. If the training data has biases, the complex interactions in an MAS could potentially amplify them. Plus, implementation costs are high. These systems need significant infrastructure.
And what about the patient perspective? The black box problem.
That's a real concern. Patients understandably worry about decisions being made by AI without clear human oversight and transparency.
And it gets even trickier when agents from different organizations are involved, right? You mentioned security.
Yes, these cross-domain MAS introduce unique security headaches. Imagine new, perhaps unvetted, AI agents dynamically joining a team. How do you manage trust? What about collusion, where agents might coordinate hidden agendas?
Or just conflicting goals. My agent wants what's best for my hospital, yours wants what's best for yours.
Precisely. Conflicting incentives can lead to agents manipulating or withholding information, and tracing actions back provenance becomes really hard across different organizational boundaries. Who influenced what decision?
Okay, that sounds like a minefield. What are the solutions being proposed?
For data and privacy, people are working on better data integration standards, using privacy by design with techniques like differential privacy or homomorphic encryption, maybe even blockchain, and federated learning where data stays local.
For bias and the black box.
More clinician training, continuous real-time safety monitoring of the MAS, maybe adversarial training to make the system more robust against manipulation, and even using a meta LLM controller to help resolve conflicts between agents.
And for those cross-domain security issues.
Things like neural provenance tracking are being explored. Think of embedding unique signatures, like digital watermarks, in each agent's output. That could help reconstruct the chain of contributions and identify any malicious influence.
So lots of work being done, but still significant challenges.
Absolutely. And it's crucial for you, our listener, to grasp that these aren't just abstract technical problems. They directly impact trust, safety, fairness. How these incredibly powerful tools will actually serve people in critical areas like healthcare.
We have covered a lot of ground today. It's been fascinating exploring the potential of LLM as a judge and these multi-agent systems. You can really see how they could, well, revolutionize complex fields like cancer care, offering efficiency, accuracy, personalization.
The promise is definitely huge, truly inspiring. But as we've discussed, there's a significant path ahead. We have to tackle those technical, ethical, and regulatory hurdles head on.
The biases, the hallucinations in LLMs, the security complexities, that unpredictable emergent behavior in MAS.
Yeah, addressing all of that is absolutely vital if these systems are going to be deployed responsibly and effectively.
So here's something to think about. As these AI agents get better and better, not just at giving us information, but at actively judging, evaluating, collaborating, basically mimicking expert human teams in critical decisions. What does that mean for us? What new kinds of human-machine partnerships might emerge?
And maybe more importantly, what are the profound responsibilities we as a society need to take on to ensure these powerful, intelligent judges truly serve humanity in a way that's just, reliable, and ultimately beneficial?